Well, good afternoon, chemistry students. I'm going to do a follow-up video for today. Hopefully I can get this posted and out a little bit quicker than the last one. Two reasons. One, I got a question from one of you on something I thought I could answer. Two, this morning's video actually didn't record everything that I wanted. There was another practice problem that was supposed to be at the end that I don't know if I ran out of space on my camera or what happened, but it wasn't there. So, the question I received online was about the spin quantum number. How do you know if it's a positive 1/2 or negative 1/2? So I thought, let's go through that in terms of another practice problem. We're going to find a set of quantum numbers that describe the last electron in cobalt. So again, I look at the periodic table. The periodic table says cobalt is number 27. 27 electrons. So I'm looking at my list. 20 electrons is 4s2, so that's going to be full. 30 electrons takes us up to 3d10. Well, so I'm only going to have 7 in there, 27. So I'm going to end up with 3d7. So right off the bat, the first two quantum numbers are pretty easy. That last electron is in the third energy level. That's the first quantum number. The last electron is in the d sublevel, SPD. Second quantum number is 2. When we want to figure out the third quantum number, D has 5 blanks, 5 orbitals. They range from whatever this number is, that's a 2, so it goes from -2 all the way up to +2. Now, 7 electrons. And electrons are going to be represented by arrows. So, I do an up arrow to represent the first electron. Now, that's the first electron in orbital. So if that was the electron I'm talking about, that electron would have a spin quantum number of positive 1/2. The first electron always is a positive 1/2. My next electron goes here. That electron, its orbital is -1, and it's the first electron, so that's a positive 1/2. Third electron, its orbital is 0, positive 1/2. Fourth electron, its orbital is +1, positive 1/2 spin. Fifth electron, its orbital is +2, positive 1/2 spin. Now that I've got 1 electron in each, I go back and I start doubling up. So my 6th electron went into the -2 orbital, and that was the 2nd electron in there, so that electron has a value of -1/2 for the spin. The 7th electron, here's the one we're looking for, 7th electron ends up in the -1 orbital, so my third quantum number is -1. It was the 2nd electron in the orbital, so it has a -1/2 spin. I'm hoping that clarifies the question I received about the spin quantum number +1/2 or -1/2. Now, I want to do, this is the example that got cut off this morning. What if we have a set of quantum numbers and we want to work backwards? In this case, it's asking us what atom has its last electron described by 520 -1/2. So let's try to work backwards. That first quantum number indicates the energy level, 5th energy level. The second quantum number indicates the sublevel, SPD. So it's in a D sublevel. When I get to the last two quantum numbers, I'm going to use my orbital notation. I know that in D sublevel there's 5 orbitals, ranging from -2, -1, 0, +1, +2. What I'm going to do is I'm going to start filling electrons in until I get to this combination, until I get to the zero orbital with the minus 1/2. So I put one there, there, there. We'll stop and look. It's in the right orbital, but that was the first electron that we put in there. So that one has a value of plus 1/2. So we keep going. Start filling up again. That last electron that I drew, you highlight it in red, that last electron is in the zero orbital, and it's a second electron, so it had a minus 1/2 spin. Okay, now once we have that, we can count and say, well, I had 1, 2, 3, 4, 5, 6, 7, 8. I had 8 electrons all together. 5d8. Where does that end up? Here's 5d10 is at 80 electrons, so 5d8 must be 78 electrons. Atomic number 78, we look at our periodic table, is platinum. So there's an example working the opposite way. I hope that helps. Hope that clarifies some questions. Please, if you have questions, ask me. I will try to get answers to you.